Good morning, everyone. In today's class, we are going to discuss the Palo Alto Firewall product portfolio history. We have already seen, right? We have discussed the history yesterday. We have discussed the stateful inspection yesterday. What is firewall? This also I have covered. Apart from those things, I have also covered some small topics, right? Now, in today's class, I directly start with the Palo Alto Firewall product portfolio. Palo Alto Firewall operating system, hardware models, VM series models, and the most important topic, which is SP3. Then the initial access, and if time permits, I'll cover your packet flow as well. So those are the things which I am planning today. Just give me a second. I have to open one document actually. Let me fetch that one. My desktop, where is this? Life of a packet. And guys, if I'll share those documents, do not put on the LinkedIn, please. Okay. Because those things you will not find in the LinkedIn. So do not paste over there after taking the screenshot and all. Just keep with you only. Okay. So let me start with the Palo Alto Firewall product portfolio. So, guys, if we will discuss the Palo Alto Firewall product portfolio, then Palo Alto offers three type of solutions majorly. Majorly, it offers the devices for three type of security. The first solution they have offered basically for cloud based devices. What they've offered for the 1 minute. This Epic Pen is having lots of issues nowadays. Okay, so if I'll talk about the Palo Alto Firewall product portfolio, so we have a Palo Alto offers three type of product portfolio. First product portfolio name is Strata. Strata. Second product portfolio name is Prisma, and third one they call it as a core text. Those are the three type of products which is offered by the Palo Alto Firewall. Now, our product, which is your Palo Alto Firewall, it comes under the Strata product portfolio. Okay. So, Strata product portfolio majorly have a devices like your Palo Alto Firewalls. Firewall comes under this. Panorama is also comes under this. Then there is a one more device called WF500 Wildfire Appliance. That device also comes under the Strata verdict only. And this startup product portfolio basically protect us, or we have to deploy into the hybrid data centers, internet perimeters, branch and mobile locations, 5G and IoT location, and also in the endpoint location. Okay. This particular Prisma solution they have released for securing the cloud-based applications. If you want a cloud-based security, then you have to go with the Prisma solution. In Prisma solution, they have a two type of solution or like for the cloud-based solution, they have a two solution. First one is known as Prisma Access, and second one is known as Palo Alto SD-WAN. And third solution, which is code text, it is basically it will secure the future. Future means let's suppose you have a logs, then how you can basically securely save your logs somewhere. Okay, it will basically provide the endpoint security. Do you heard the name of Palo Alto Traps? It is a similar kind of solution. Detection and response, automation and orchestration, mobile network traffic and the behavior analysis and the threat intelligence. All those things comes under the core text verdict. So those are the three types of product portfolio offered by the Palo Alto Firewall. If I'll say your in the strata, it comes under the securing the enterprise. So your next generation firewalls, Panorama, Wildfire, Global Protect, and also they have put here Prisma Access, but Prisma Access is not a solution here. Okay, mostly Prisma Access we will use for securing the cloud. But nowadays, what we can able to do this Prisma Access, because you know this SD-WAN solution. Nowadays, we are deploying the SD-WAN routers into the branches. And if you know, nowadays, whatever the SD-WAN solution is created by the different vendors, what they are keeping 60% security component on those devices and 40% networking component. Means now your SD-WAN routers, they can also able to do these firewall functionalities. Okay. So that is the reason they have put here SD-WAN as well. But you know, SD-WAN generally we used to deploy at the branches. And for the securing the cloud, we have a Prisma Cloud. Now here they have a couple of other solution. It's not only the Prisma Access. Okay. We have a Prisma Access. Apart from Prisma Access, there is a one more very nice solution. They have a Jet TNA. They have a proxy, secure web gateway. All those things comes under the securing the cloud. And securing the features, they have a Cortex Data Lake, Cortex XDR, prevents malware, block exploits, analyzes PCS patterns through the behavioral threat protection. Cortex XOR enables security teams to accelerate the response across the people, process, and technology. Cortex Data Lake for the logging solution, XDR for the endpoint security. Okay. Now, if I, because we are here for the Palo Alto Firewall training. So if I talk about the Palo Alto Firewall, so as I mentioned yesterday, Palo Alto Firewall is released in 2015. It is introduced in 2005, sorry, not 15. It is introduced in 2005. And just within 3 years of time, in 2008, this firewall become the #1 firewall, and it start leading the firewall industry. And if you will check the Magic Quadrant for of the Gartner reports, then you know in the next generation firewall, Palo Alto is in the leaders quarter and it is on the top. The second one is Fortinet, then we have a Cisco and Checkpoint. So those are the four next generation firewalls majorly. Then in challengers quadrant, they have a Huawei. In the visionaries, they have a Forcepoint. Then the and the last, they have a Sophos, Juniper Networks, Barracuda, and others firewalls. Okay. But your Palo Alto firewall is the market leader since 2008 till today. Why this device become market leader? Because Palo Alto was the first firewall who comes with the features like app identification. Means now you can able to write the rules on the basis of applications on the Palo Alto firewall. Palo Alto introduced the features like user ID. You are not only rely on the source and destination IPs. Now you can just write the rule on the basis of username, user groups, and the content ID. Means you will get the IPS functionality built in within the box. But in that era, people uses the IPS device for that. Okay, so guys, how they have basically, so Palo Alto generally is a city in California, San Francisco area in USA, and this next generation firewall name they have kept according to that city name only. Okay, PA is a USA multinational cybersecurity company. They have a headquarters in California, and Palo Alto Networks was founded in 2005 by the Israeli American. His name is Nerzuk. Nerzuk is a former engineer from Checkpoint and NetScreen Technologies. Palo Alto having world-class team with strong security, and these are just the normal stuff. Okay, now let me just discuss now three things, guys, here. Let me just explain you the Palo Alto operating system, which is most important part. What is this PAN-OS? So guys, in your Palo Alto devices, we have a Palo Alto firewall, right? Any, either it's a hardware, or it's a virtual, or it's a cloud native. Cloud native firewall, okay? Guys, they are running one operating system, right? We need a operating system, right, to interact with the hardware. And that operating system which are running on those Palo Alto firewall is known as Palo Alto operating system. Then how they have built this Palo Alto operating system? So guys, do you know there's a one Linux flavors we are having, BSD Linux? Have you heard that Linux name? It's an open source platform. Do you know what is open source? Open source means this particular operating system, BSD Linux, actual source code you will get over the internet. That is open source. And most of the Linux flavors are the open source. Like Ubuntu is not open, so it's a proprietary one. Red Hat has a two flavors. There is a one flavor is the open source, and another flavor is not free. Okay. And if you will basically, even if you will search on the Google, let me give you here. If you will search in the Google, BSD Linux source code download. If you will search like this, then you will get that BSD Linux source code. See, all the files you will get here, everything, entire source code is available free. You can just download and you can do the customization according to your requirement. Source code is available, even though you can able to also download from here. See, no, sorry, these are the installer, I guess. Choosing the image, this is the software version. Let me just select for AMD 64. See this, okay, this is the software we will get, I guess, from here. But this is the actual source code of BSD Linux. Now what they have done, now see, I have received the source code, right? So what they have done, they get the source code of BSD Linux. See, now I have a code actually. I have a source code of BSD Linux. After getting this source code, what I have done, or Palo Alto have done, they did some customization. They did some customization, right? Now they got the customized version of BSD Linux. On top of this customized BSD Linux, they have put the PAN application. See, I have a operating system, right? Customized version of BSD Linux, and I have run the PAN application on top of this. And this entire thing is known as PAN OS. This entire thing is known as Palo Alto operating system. So the Palo Alto operating system is a customized version of BSD Linux. Now, guys, do you know? Let me give you one basic example. See, let's suppose on Linux machine. This is only for the people who has some experience on the Linux machine. In Linux machine, let's suppose if you want to run the SHS service, then what is the process name? SSHD. If you want to run the HTTP process, then the process name is HTTPD, HTTP daemon, right? So, guys, because see, to run the SHS service, there is a SSHD process is running. To run the web services, we have a HTTPD. Similarly, what is PAN-OS? PAN-OS is a customized version of Linux, which means this particular, because it's a Linux only. In a backend, it's a Linux only. On top of this Linux, we are running PAN application, which means if I want to run the SHS on my Palo Alto firewall, then there is a one SSHD service is running. If I want to configure SMTP, then SMTPD process will be there, who will take care of all the SMTP related tasks. If I want to run the SSL process, then there is a SSL manager process is running, SSL MGR. Okay. So similar type of daemons is also running in your Palo Alto firewall. Just remember. And where all those daemons used to run, they used to run into the management plane. Palo Alto have a two planes, data plane and management plane. And those particular daemons, they used to run into the management plane. Most of the daemons, they used to run in the management plane. Where? In the management plane. Okay, just remember that. Any questions, guys, with regards to Palo Alto operating system? It's easy. It's a just the very short definition. It's a customized version of BSD Linux. It's just a customized version of BSD Linux. So Ankit asked, we can change the daemon path. You are not able to do anything with PAN OS. Why? Because root access is not available. Root access is not available for anybody. Root access is not available for anyone. Just remember. Okay. If you want to get the root access, there, like, you will not get the root access. There is a tech engineers who is in the tier 3 level. Those engineers only able to get the root access, and there is a proper process for that. There is a proper process for that. They have to follow that process, and then only they will get the root access, and after that they can able to perform the root level task. Okay, so whenever we are configuring the Palo Alto firewall, you are not having root access. Just remember, you are just logging there as a normal user. They call it like admin is a super user, but that particular admin is not, in actual, it's not a super user. It is not having the root privileges. You cannot able to run any Linux machines. You just have access of PAN applications, not the Linux environment. If you got the Linux environment access, then you can do all the modification, right? And let me tell you one story. Like around somewhere around in 2010, what Palo Alto used to do, they used to provide the root access to customers easily. So there is a one customer in USA. So there was one engineer, and what that engineer was a developer initially. In initial days, he has joined as a developer. Means he was a very good coder. Okay. He got the root access of Palo Alto. So guys, when you will purchase a Palo Alto box, let's suppose you have purchased a Palo Alto box like PF440. Then 440 have a session limit of 64,000 sessions only. See, that device is capable to handle more sessions, but that limit they have kept. Palo Alto have kept. So what that engineer has done, he has just modified that particular limit. He has increased that limit. And after that, that box able to support more sessions, whatever Palo Alto claims. Okay. Right. Let me show you that limit. So if you will get the root access, then you can able to do those changes. So they never provide you the root access. Not this one. I have to open. Where is my device? First of all, let me delete those sessions not needed at all. Like if I run this command, show session info, there is a one command. You can see this particular box supported around 1,99,998 total session. This is the session capacity. So what I can do, I can able to modify that capacity. If I'll get the root access, I can able to do those modifications. Okay. So root access is not available. Okay, just remember. Don't worry what is session, everything you will learn. Okay. Don't worry on that. Session means this you can think like it's a capacity. How much food you can able to eat, it's like that only. How much, how many, like let's suppose you can only able to drink like 2 beers, right? So it's like that only. It's a capacity of a device. How many sessions it will support. Now, let's try to understand guys, Palo Alto Firewall devices or hardware appliance and the VM series appliance. So Palo Alto offers three type of appliances: physical appliance, which is also known as hardware appliances; virtual appliances, which is virtual appliance generally are the VM firewalls for different type of hypervisors. Do you know what is hypervisor? Hypervisor is a virtual environment where we used to run our machines like VMware, ESXi. Even though your cloud solution like AWS, Azure, GCP, Oracle, right? All those they will just provide the virtual environments only. They are running hypervisors in backend. Okay. And there is one more series which is a CN series firewalls or the cloud native firewalls. Okay. So let's try to understand the hardware appliances. Guys, at least remember those names. You have to remember the names of second generation firewalls and third generation firewalls. First generation is okay. So first generation firewall means when Palo Alto is introduced in 2005. Those are the hardware appliances which is launched by the Palo Alto. So they have a PA 500 series. In 500 series, they have a PA 500 and PA 500R. If you will see R at the end, which means this device they have designed for the locations where we have a humidity, like Chennai. Near to Chennai in India, we have a sea, right? So it's a humid area. So if you have a humidity in your area, then you have to go for this R box. Okay. Then they have a PA 200 series, sorry 2000 series, where they have a PA 2010 and PA 2020. 3000 series and 5000 series. There where they have a PA 5010, 5020 and 5030. So those are the first generation boxes. After that, they have released the second generation boxes. What they have done now, tell me one thing. Very small question, guys. Tell me one thing, guys. See, when you let's suppose you guys have started using Facebook since 2012. What was the application? Let's suppose we used to install the application in our laptop, right? In our mobile phone. What was the application size in 2012 for Facebook? Maximum 3 to 4 MB. But nowadays, have you checked the nowadays what is the Facebook application size? Somewhere around 150 MB. Yes or no? Even though, because as time grows, your technology will also grow. In initial days, we used to have a very low internet speed, right? But nowadays, we have a very good internet speed, right? Which means because your internet speed is increased, if your internet speed is increasing, right? Your application size is increased, right? Facebook was 3 or 4 MB, now it's 150 MB. So when those particular application size increase, and also let's say previously when you used to have a mobiles, they used to have a very less RAM, like 1 GB RAM. But nowadays we most of the peoples used to have a RAM in your mobile phone at least 8 GB, 12 GB, right? That is the story nowadays. Means you are having a device which are capable enough, right, to do multiple tasks at the same time. So do you think the hardware appliance, whatever the RAM, whatever the chip we are using for CPU and whatever the RAMs we are having, what is the hard drive we are having on those devices, are they able to capable of handling today's load? They are not able to handle today's load, right? And even though day by day technology also used to enhanced, right, for your hardware level, like for your CPU chip and all, right? So what they have done, uh, the new hardware or the very fast hardware, very fast or very high end computing chip they used to implement, and those devices is known as a second generation firewalls, where they have added lots of, like might be in those devices they are having DDR3 RAM, but here they have a DDR4 RAM. Okay, might be whatever the CPU it is having, let's say it's a CPU with 64 core, but nowadays they have a 128 core of the CPUs on those boxes, right? Because load is increasing, right? So they have to also improve the hardware resources, because by end of the day, throughput of your any device will be measured according to their resources only, right? Because if you have a less resources, then throughput is very less. If you have a good resources, then you will get a good throughput, right? So they have launched the second generation boxes, where they have a PA200 series, PA800 series, PA3200 series, PA5200 series, and PA7000 series. Okay, so those are the second generation boxes. In PA200, they have a PA220 and PA220R. In 800, PA810, 820, 850. In 3200, 3210, 3220, 3250, 3260. In 5200 series, 5280, 5260, 5220, and 5210. In 7000 series, PA7050, 7080. Okay. And after that, the latest series which right now is running in the organization is the third generation firewalls. In third generation firewalls, we have a PA400 series where we have a PA410, 410R, PA415, PA440, PA450, and PA460. 1400 series, PA1410, 1420, 3400 series, PA3410, 3420, 3440, and 5400 series, and the 7500 series. So those are the latest series which is known as also third generation firewall. So those are the hardware models which is offered by the Palo Alto firewall. Now, your PA200 series here and your PA400 series here, those particular hardware appliance is for the small business units, SMU organization, small business units, for the small organizations where you have a user count minimum is 50 to 100 or 150. If you have those type of users count, then they recommend you can deploy the PA200 series, either PA400 series boxes. This is for the small businesses. Like let's suppose in your branch you have a 20 people, so 30 people are working or 100 people are working, then those devices are enough to share that much load. For the medium sized organization, they have offered P800 series and PA3200 series in second generation, and in your third generation, PA1400 series and PA3400 series. Those are for the medium sized organizations or medium sized business units. Okay. And you know guys, PA5200 series and 7000 series for the data centers. Here 54 and 7500 series for the data centers only, where you have a throughput, where you need a throughput in GBs. Okay, so that's how they have released those particular boxes. And most of the time nowadays in India, in most of the customers, they are having this particular series. If you have a less data centers, then 5410, 5420, and 5430 is enough, and also 5440. But if you have more, then these are the two series. If you have a more, you need a more throughput. Okay. So this is how they have basically launched the different box. Now generation wise, as I have mentioned, what they used to change, they used to upgrade their hardware appliance in a backend, like their CPU version, CPU core, their RAM, SSD, those things they used to update in each and every generations. Okay. And like whatever the latest technology they are running on those CPUs and all, they uses those particular chips. And guys, let me tell you one more story here. See, all the devices of Palo Alto, they uses the Intel chip only. They uses Intel chip only, but you know, this Intel company, how they basically design their chip according to the Palo Alto devices. They used to design the chip according to the Palo Alto devices. Okay. And after that, Palo Alto used to implement those chips into their hardware appliances. So those are the hardware models which is available from the Palo Alto. So, and also guys, one more thing. See, If I'll talk about the PA 7000 series, 7K box of PA 7500 series, those are the chassis based firewalls. Chassis based means you will get a multiple slots over there. Okay. So those are the, this is the picture of your Palo Alto 7000 series of 5000, sorry, 7000 series boxes. PF 5440 and 5450, it is like a small, like you will, it's not a very big box. You will see the box like that only. But color they have changed. Okay. In your second generation boxes, color was this only. You will see the firewall with this color. But nowadays, whatever firewall you are receiving, they are in the white color. So third generation boxes are the white colored. You will see the white type of color. Okay. Because I have deployed multiple firewalls of PA5440, PA5445, and PA5420. I did multiple migration, I think few days back only. Now, Palo Alto do offers VM models or virtual models, VM series models according to the capacities. So they have a VM 700, VM 500, VM 300, VM 100 and 200, and VM 50. And most of the time, whatever you will install in your lab, it's VM 50. Even though in my lab also, if you will see here, this firewall is a VM 50 only. It's a VM 50. I do have other series as well. Like if you will see those two, they are not turned on right now. They are the VM 300. But why I'm not running those firewall? Because they needed lots of resources. Okay. Because my lab is runs very good with VM 50. So I also uses VM 50. But the difference is with the throughput only. Why like VM 700 have a high throughput? Because it has it has a large CPU, like 16 CPU will be there. 56 GB of memory is there, right? Dedicated disk capacity of 60 GB is there. So that is the reason your BM 700 basically has a high throughput. But nowadays, see, nowadays, if you will deploy those VM series devices in the cloud environments, right? Then you will not able to see VM 700, 500, 300, those type of stuff. Those are for the private hypervisors. Private hypervisors means the VM environment which is owned and controlled by your organization. Like you are running hypervisors like ESXi, KVM environment using Red Hat, which is somebody have the name had the name of OpenStack, right? If you want to deploy the Palo Alto there, then you have to basically think about those capacities according to those VM based models. But nowadays, if you are deploying the Palo Alto over AWS, GCP, Google Cloud Platforms, Azure, Oracle, when you will deploy, so when you will deploy those here, totally this deployment is dependent on the how many CPU core you have selected, how many RAM you have selected, and how much hard disk you have selected. Okay, because and also you will get the license as well here. By default you will get the license, and when you will use those devices in the cloud environment, the cost will be go to AWS when you will pay, and also the some part of the amount whatever you will pay go to AWS or those public cloud providers, and also some part used to go for the Palo Alto. It's like that only. Okay. And after that, basically, they have also created a new firewalls for Kubernetes. Nowadays, guys, if you will heard the name, most of our applications, they are running over the hypervisors and you are managing through the Kubernetes clusters. And they are running as a Docker images, right? If your applications are running over Kubernetes or Docker, right? And now let's suppose you are not running single application, multiple applications you are running, right? Let's suppose those are the 8 applications you are running. Now, if you want to protect the communication which is happening between those 8 applications, then you also need to run a Palo Alto Firewall as a Docker image. So it will basically protect the communication which is happening between those particular applications. So they have created a container native series firewalls or CN series firewall. CN series firewall provides visibility and security to the containerized application workloads. Natively integrates into the Kubernetes clusters, provide layer 7 visibility, application level segmentation, DNS security, and advanced threat protection. Protects traffic across the trusted zones in the public cloud or the data center environments. If somebody is not able to understand what is Docker and Kubernetes, you can read over the internet after this class. And one more thing. So this is clear, guys. This series, because in interview they will ask, can you name some of the firewall hardware appliance? Then you have to tell some names from the second generation list, some names from the third generation list. Now, guys, let's try to understand the most important topic for today, which is SP3, single pass software and parallel processing hardware. Danesh, I'll cover your question in the Q&A session. Okay, don't worry. CN series firewall just for the Kubernetes cluster, because you guys is not having any idea how Docker works, how Kubernetes works. So you might not able to understand. Okay, but not an issue. I'll show you some images from the internet, how Docker works and all. Okay, now just focus on the SP3 architecture, guys, because this is the most asked interview question. Let me know if are you able to see this particular data path. No. So what I'll do, I'll take a reference from this data path and I'll also take a reference from here. Okay. So what do you mean by the SP3? SP3. So SP3 basically is a combination of two things. First thing is single pass software, and second thing is parallel processing hardware. So what is the full form of SP3? SP3 stand for single pass software and parallel processing hardware. Now in the interview, how they will ask this question? They will ask these questions in three ways. Maybe they will directly ask you, can you explain SP3 architecture? Or maybe they will ask, can you explain the Palo Alto Firewall architecture? Or they may ask, what is the parallel processing hardware architecture of Palo Alto? Or what is the single pass software architecture of Palo Alto? So they will ask the questions in this way, but explanation is similar. SP3 stand for single pass software and parallel processing hardware. So guys, to understand this entire SP3, let me first cover the parallel processing hardware. What is this parallel processing hardware? Okay. Now for that, I will take one more reference here actually. Just give me a second, okay? And I'll recommend everyone to go through with that particular video. This is mine video only. MP, come on. I'll share this link. Save this link somewhere. Because you know this diagram I don't have right now. That is the reason I'm taking the help from YouTube channel. Just go through with that. You will get the idea what is management plane, what is data plane, how they are connected and all. Okay. But you know, whatever I needed, I have here. Okay. Now, so to understand the parallel processing hardware, you know, guys, in Palo Alto Firewall, basically, we have a two things. In Palo Alto Firewall, we have a two things. We have a management plane, which is this one, and we have a data plane, which is this one. So in your Palo Alto Firewall, we have a separate management plane and we have a separate data plane. Means Palo Alto Firewall hardware is divided into two parts. Management plane and the data plane. Now, this management plane has a separate task to do. It has a dedicated responsibilities to perform. And your data plane has a dedicated responsibilities to perform. Okay. So first of all, what Palo Alto have done, they have done the segregation of management plane and data plane. Okay. They have basically, and also one more thing, that particular, this management plane, it has his RAM and CPUs. RAM and CPUs, dedicated RAM and CPUs are available into this management plane. It is not having any type of dependency. There is no dependency. So what happens basically? The Palo Alto Firewall management plane. Generally, they name it as a control plane, but I don't like this name control plane. I always put this name as a management plane, MP. Okay. So you know this management plane is responsible for configuration management. Whenever you are doing any type of configuration in this particular Palo Alto firewall via CLI, via GUI, or via API. If you are doing any type of configuration changes, those configuration changes is handled by the management plane only. Management plane CPU and RAM is utilized in this task. Your logging, whatever log is generated in your Palo Alto firewall, this is also handled by the management plane. And the reporting, whenever you will generate any type of report in your Palo Alto firewall, that reporting task is also done by the management plane. And you know guys, if you will see, it has a dedicated CPU, dedicated RAM, dedicated SSD, hard disk, dedicated management interface, and dedicated console port, and also dedicated HA1 interface also, your high availability one. There's a HA1, HA2, and HA3 interfaces. So in your HA class, I'll cover. But you know, HA interface is also a part of your management plane only. Okay. So what is the task of management plane? Configuration management, reporting, and logging. Those three tasks is done by the management plane. It has a dedicated task to do. Means management plane will not process any type of users traffic. Let's suppose any user trying to communicate with the Facebook through our firewall, then that particular traffic is handled by the data plane. It is not handled by the management plane. Management plane will not handle any type of users data. Just remember, users data is not handled by the management plane. Just remember. Okay. It is handled by the data plane only. Okay. Apart from this configuration, logging, and reporting, as I mentioned, what is the operating system in your Palo Alto? PAN-OS. PAN-OS is a customized version of customized version of BSD Linux, which means all the daemons, all the processes. Daemon means process. They are running actually. So if you will see here, I have a management plane and I have a data plane. Okay. Now in this management plane, if you will see here, this is my management plane. Your system daemon, your master D manager, one core of master D manager is running into the management plane. Your REST manager, VRD agent, HA agent, FBEP3, where receiver, crypto D, EHMON, route D for routing related task, right? SysD agent, F manager for interface related task, DSCPD, DNS proxy, auth D for your authentication related task, right? IK manager for VPN related task, key manager for key management, Dagger, SMTPD, SSL manager for SSL related task, log receiver, your logging related task, user ID for user related task, management server, when to manage the connectivity with the panorama and all, and your device server. All those daemons, they are running in your management plane. So apart from configuration management, reporting, and logging, what we have in the management plane, most of the daemons, they are running into the management plane. Okay. So if you will see in data plane, we have a very less daemon, like one core of master D, then sysd agent, tunnel D, pen task, supervisor, pen DHA, EHMON, BRD agent, MP relay, and pencom. Those are the daemons. They are running into the control plane or the data plane. Why I don't mention here as a control plane? Now you got the answer, because inside data plane there is a one control plane part is also there, and that control plane have those three daemons. But you know, if you are from the tech background, then only you will understand those things. So that is the main reason they mention as a control plane, because that information is not for the normal peoples. Okay, so that's why always I call it as a MP, management plane, DP as a data plane. In data plane, we have very less daemons. I'll explain you the functionality of each and every daemons in the future classes. Don't worry on that. But here, just understand, in your management plane, configuration management, logging, reporting, plus daemons or Linux processes, they are running in your management plane. So those are the tasks of management plane. Okay. Now, come back here. Apart from this management plane, this Palo Alto Firewall have a data plane. This is the data plane of your Palo Alto Firewall. This plane is known as a data plane of your Palo Alto Firewall. Now, what Palo Alto have done? Palo Alto have divided its data plane into three another planes: networking, security, and content. This is known as networking, means it is known as network processor. Security means it's a security processor, and content processor is known as a signature match processor or pattern match processor. Means now your data plane is further divided into three another planes. Now what those planes will do? See, data plane is divided into three parts. Signature match processor. So guys, do not worry about this information what they have written here. Signature match processor is responsible for two tasks: application identification and content ID. These two tasks is performed by the signature match processor or pattern match processor. It is a dedicated hardware chip. It's a dedicated hardware chip. Then we have a security processor. Just do not worry about this app ID here or user ID here. Security processor, what it used to do, this particular processor will process the packet from layer 2 to layer 4. Layer 2 to layer 4. On the basis of layer 2 to layer 4 information, your security processor will perform the task. Apart from this, in your Palo Alto appliances, they have a dedicated SSL chip and dedicated IPsec chip for performing the SSL related task and IPsec related dedicated hardware chip they are having for performing those tasks. Apart from that, they have a network processor. This network processor is also known as a session offloader. Like you can think like that. This is you. Security processor is you. Then you have a network processor, which is the just a helping hand for you, like your secretary. Whatever task you will assign here, because you know network processor can process the packet from layer 2 to layer 4. Those layer 2 to layer 4 tasks, this can also do, this can also do. But your network processor will only do the task which you will offload from your side. Whatever instructions you will give to this network processor, those tasks only it will perform. Means let's suppose there is a one session, there's a some flow is going on, so there is a one session is created. If my security processor say session number 100 you have to handle, then this particular processor will handle session number 100 only from layer 2 to layer 4 point of view. Okay, so those are the three processors they are having at the data plane. Now guys, those processors, They are independent on each other. They have a dedicated resources, which includes like RAM and CPU. They have a dedicated resources to perform the task. They don't have any type of resource level dependency on each other. That dependency they are not having at all, which means network processor can handle the traffic, security processor is also handling the traffic, and content engine is also handling the traffic. There is no dependency at all. And one benefit you will get, because those are the dedicated chip we are having, right? If one of the chip gets overutilized, then it will not affect the functionality of other two chip or other two processor. Why? Because they are not having any type of dependency at the resource level. Have you heard the name of deadlock conditions? In routers, most of the time you will see this problem, deadlock problems. Why? Because let's suppose if one of the process got hanged, what it used to do, that process will consume the entire RAM and CPU of your router, and other processes will not get the CPU and RAM to do their task. So in your Palo Alto firewall, you will not face the problems like deadlock, because they have a dedicated CPU, they have a dedicated task to do, and they have a dedicated resources at the processor's level. Now, one more thing. See, if we have received a packet, let's suppose packet number 1, 2, and 3 is on this chip, packet number 4, 5, 6 on this chip, 7, 8, and 9 on this chip. And you can see all those chips, they are processing the packets at the same time. It looks like they are working parallelly. They are handling the data traffic parallelly. That is known as parallel processing hardware architecture of your Palo Alto firewall. That is the parallel processing hardware architecture of Palo Alto. Now, let me now go beyond this discussion. It's the same information. Your control plane or your management plane will handle the management functionalities provided by the dedicated control plane processor, drives configuration management, logging, reporting without touching the data processing. Palo Alto control plane or management plane has its own CPU core, own dual cores of CPU, dedicated RAM and dedicated SSD. I think here I have to update this note. It's a dedicated SSD. Okay. Now, data plane, Palo Alto data plane. It is the traffic forwarding plane with different chipsets. Means at the Palo Alto data plane, we have a different chipsets, and this is the plane who will process the actual user's traffic. Three functions, three functions: signature match processor, inspect the traffic, build a regular expressions. The second function is the security processor, matches against the Palo Alto security policies, and the last function is the network processor used for the traffic forwarding etc. Now, network processor will can process the packet routing, flow lookup, stats, counts, net, and all performed on the network processor. So means L2 to L4 processing it can able to do. Security, user ID, app ID it will not do. Policy engine all occurs on the multi-core multi-core encrypting, decryption, decompression, all those tasks done by the security processor. You know, guys, why they have mentioned app ID here? There is a one technique they have introduced in the silo path. If you remember, they have introduced one technology called app ID cache. That is the reason they start adding here app ID. Otherwise, that terms not required here. Signature match procedure is responsible for your app ID and content ID related task. I wanted to show you something actually. Yeah, this is the architecture of Palo Alto. '5000 series box. In this particular architecture, if you will see, we have a dedicated, this is the management plane, MP, and this entire thing is known as data plane. In management plane, you can see it has a dedicated CPU, dedicated RAM, dedicated SSD, right? And after that, this is also known as switch fabric. Do you heard the name of interface module, guys? Anyone has inserted those interface module or ordered any interface module when you have created the bill of material, BOM? If you don't know, so there is a one interface module where we used to, that module we have to insert, and it has all the ports and all where we used to connect our interfaces like RJ45 ports, you will see some SFP ports, you will see some QSFP ports, you will see, right? Those fiber ports and all. So all those things is known as a switch fabric. And we have a Petra chip at the switch fabric level. Okay. And after this switch fabric, we have a network processor. Network processor, and you know, guys, in PF50, in PF5000 series boxes, this network processor chip name is a Tiger chip. This was the name actually. So it was a Tiger. So I will not mention here as a chip. It's a FPGA. FPGA stand for Field Programmable Gateway Array, or ASIC. It is a kind of chip only. Okay. So the chip name was network processor. A network processor can able to perform, understand your layer 2 information of the packet, layer 3 information of the packet, and layer 4 information of the packet. And after that, we have a security processor. This one is the security processor. And you know, guys, we are not having the single processor, single security processor. We are having here three different chip, and that chip name was Octeon. This chip name is Octeon. This is the Octeon chip 1, or I can say, come on, just give me a second. This is data plane 0, DP CPU 0, this is data plane CPU 1, and this is data plane CPU 2. And you know, guys, this particular all the CPUs, they have a dedicated RAM, dedicated CPU cores, and they have a dedicated SSL chip for SSL functionality, IPsec chip for IPsec functionality, and decompression chip for decompression related functionalities. Now here we are not having only the single CPU, here we are having three data plane CPUs, three Octeon chip at the security processor level. I'm talking about this one. I have started the discussion from this diagram, right? I'm talking about this chip. It's a data plane CPU. This chip is also known as DP CPU. Now in high-end boxes, I'm not only having the single DP CPU. I have a DP0, DP1, and DP2. Okay. Three chip I'm having in the high-end boxes. Okay. Now, Apart from this three data plane CPU, I am having signature match processor, and the chip name for signature match processor is Jaguar. Jaguar was the chip name. This is also a FPGA, which is Field Programmable Gateway Array, or the ASIC. And we are not having single chip. We are having here chip number 1 and chip number 2. Two Jaguar chip we are having. Right? This is DP0, DP1, DP2. Now let's take an example. Let me show you something here. Let's suppose, from this PC, I have initiated some traffic towards this particular server. Let's suppose from this PC I've initiated 3 packet, packet number 1, packet number 2, and packet number 3. Maybe there is a condition. First packet processing is happening here, second packet processing is happening here, and third packet processing is happening here. So do you like, it's a parallel processing, right? All my 3 packet gets processed parallelly by the Palo Alto Firewall. Are you able to see something here like parallel is happening? We have architecture like a parallel architecture kind of thing at the security processor itself in high-end boxes, right? Then we have two signature match processor. Maybe one packet app identification is happening here. Maybe for second packet it's happening here, right? They are getting the processing, and you can see dedicated hardware they are having at every chip, right? Do you think here they have any dependency on each other for the resources? No. That is known as, guys, parallel processing hardware architecture. And you know, guys, here I have taken the reference of PA 5000 series box. So you know, guys, in high-end boxes, we used to have a 3 CPUs, DP0, DP1, and DP2. Okay. But in low-end boxes like 3000 series box, if you will see, it is not having a it only have a single CPU here, single Octeon chip. Chip name was Octeon. It has a single CPU, and it is known as DP CPU. And you know, guys, always your packet processing start from the DP CPU level. Your packet processing always start from here. Now, if that packet needs to go through the app engine and content engine, then your layer 7 data go here, and that data it will only forward here. If this DP CPU think like he can offload that session, then he will offload that session to network processor, and network processor will perform the task. And the chip name was in the network processor. So like we have a two chip mostly, Tiger chip in high end boxes and Liger chip in low end boxes. And here always we have a Octeon chip. For the signature match processor, we have a two chip here, Ocelot and Jaguar. So most of the time you will see the Jaguar. Ocelot chip was there in like old boxes and some of the low CDs boxes only. Otherwise Jaguar was the chip. Okay. So that's how they have a architecture actually. So even though they have a parallel processing architecture, right? They have a dedicated CPUs here. And those CPUs, they are functioning properly without any issues, without any dependency on each other. Now I'll take one more thing here in the consideration. What we have apart from this? Okay, let me just clean this and I'll redraw this particular diagram so you will understand it better. Okay. Okay. So now let me just draw the block diagram of Palo Alto Firewall. How was the block diagram for Palo Alto Firewall? So you know, guys, let's suppose we have a PC here having IP address 1070.1.90. I have a Palo Alto Firewall here. This is Ethernet 1 by 2. This is Ethernet 1 by 3. And here I have one of the server 1070.2.101. Okay. This is server. This is inside. And this is DMZ. Okay. Now, so what used to happen generally in your Palo Alto Firewall? Here we have an interface stack. So let's take an example. We have an interface starting with Ethernet 1 by 1. Let's say this is Ethernet 1 by 7, 1 by 1, 1 by 2, like that. Then we have a Ethernet 1 by 8, Ethernet 1 by 9, Ethernet 1 by 10, Ethernet 1 by 12. Sorry, 11. Okay. This is 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 7. Sorry, this is 8, 9, 10, 11, 12. Okay. So you know, guys, now these particular interface, they used to have a connectivity with two type of interface module or the chip. So the first chip is known as the marble chip. And those block diagram, guys, you have to remember there is no shortcut for that. Okay. And we have a Petra chip. This is marble chip. This is Petra chip. Your all the copper ports, they have a connectivity with this Petra chip. All your ports will be have a connectivity with this Petra chip. All your fiber ports. I'm just putting here, those are the copper ports. So your copper ports used to have a connectivity with the marble chip, and your fiber ports will have a connectivity. The fiber ports include SFP, SFP plus, and QSFP. Three type of fiber ports we are having. All those ports, they have a connectivity with the Petra chip. So Petra chip for handling the fiber ports, and copper marble chip, it will basically handles the traffic or the copper ports in your firewall. Now after this chip, basically what we have a here one more processor. That particular processor is known as, or I can say, I can mention, this is the Liger chip or Tiger chip. And you know guys, this particular processor is also known as FPGA, Field Programmable Gateway Array, or it's a ASIC. And this particular processor name is network processor. It acts as a session offloader. Okay. After this chip, basically, we have a one more chip. And this chip basically is known as the signature match processor. Sorry, the chip name is Octeon chip. And this is the data plane CPU. This chip basically do all the data processing. This is also known as data plane CPU. And it will process the packet, process all packets as per packet flow. And it can able to do the task from layer 2 to layer 4 processing. Okay. Layer 2 to layer 4, this can also able to do. This process can also able to do the layer 2 to layer 4 processing. And after that, we have a one more chip. And this chip is known as Jaguar chip. It's a Jaguar chip. The main functionality of this particular chip is, or this is also a FPGA or ASIC. This processor is also known as like a signature match processor. Or pattern match processor. This particular processor is responsible for app ID and content ID. And in this particular processor, we have three things. There is a one algorithm called DFA. There is a one algorithm called AHO, and it's AHO. There is a one more algorithm called PSCAN. Okay, so this is how the chip looks like inside your Palo Alto firewall, guys. Those chips, they have a connectivity like this. They have a connectivity with each other like this. What is this? They have a connectivity like this. So you know, guys, those particular links, those are the high speed fiber links in your Palo Alto firewall, and name of those links is joy links. Those are the joy links. Those are the high speed fiber links who will basically transfer the data from one chip to another chip. So that is the entire hardware level architecture of your Palo Alto firewall. Now, see, as I have mentioned, this chip called network processor or Liger or Tiger chip is only responsible for layer 2 to layer 4 processing. This chip only do the layer 2 to layer 4 processing. Just give me 1 second. It will only do the layer 2 to layer 4 processing. Now, which particular session this chip will process? All the session it will process which is offloaded by the Octeon chip. Because you know there are some of the packet actually, there are some of the traffic which Octeon chip will offload and instruct the network processor just start processing those packets. Otherwise, this processor will not do anything. It will just sit back and relax. It will do nothing. Once it will get the instructions from the Octeon chip, now this chip will start doing the data processing. And what type of task it can able to do? Layer 2 to layer 4 processing, which means it can able to do the net. Most of net can able to do ARP lookup. It can able to do. It can able to check the packet for errors. It will check the packet for errors. It will check the packets for header errors and all. That's it. Now, one question you can ask, is network processor can able to maintain the session? No, network processor is not able to maintain the session. Session management is done by the Octeon chip. Now, let me tell you one thing. See, let's suppose this particular PC is trying to communicate with one of the server here, connected by Ethernet 12, and it is connected by Ethernet 1 by 1. Now, when this particular processing will start, what it will do, when this PC initiate a traffic, so what is the first packet? Let's say it's a TCP based server running on TCP port 80. What is the first packet? First packet is send. Your send packet reach via on Ethernet 1 by 1. It will go to the Marvel chip. Marvel chip is delivered to network processor, and network processor will deliver this packet to Octeon chip. Once this packet reaches to the Octeon chip, your packet processing will start from here. What are the packet processing stages, guys? Yesterday I have told. English stage, flow lookup, slow path, or session setup state, fast path, app ID, content ID, and the forwarding. Those are the 7 stages. And you know, guys, your data plane CPU will start the ingress stage, flow lookup, then slow path. Once connection now in slow path, if my policy allow that traffic, then my connection will create. So your connection management done by the Oction chip only. Session management done by the Oction chip only, because there is one process called Azure process. Because you know we have to maintain the life cycle of the session. Azure process runs on the Oction chip only. It is not running here in the network processor level. No, nothing like that. It is just a session offloader. The session which is offloaded by the Octium chip, those sessions only it will process. That's it. Okay. And once this particular processing will done at ingress stage, flow lookup, slow path, fast path, app ID and content ID will not come in a picture because it's a TCP SYN packet. Then you know direct forwarding will happen. Now this particular packet will be delivered to Liger Tiger chip, Petra, and after that to the server. Now server will give the send the SYN plus X. SYN plus X will be processed. Then acknowledgement will be processed by the Oction chip. And after that, once your, let's suppose now we have get a new packet. We have received a new packet. Let's suppose that new packet is, let me just remove some data from here. Now let's suppose as a new packet, let's suppose I have received this. Let's suppose now I have get a HTTP GET. Now HTTP GET have some layer 7 data, yes or no? When it has some layer 7 data, now this packet will go to Oction chip. Now Oction chip will process at ingress stage, flow lookup, slow path it will not go, direct it will go into the fast path. And after fast path, what it will do? This only the layer 7 content, layer 7 information of this HTTP GET, it will provide to Jaguar chip, and Jaguar chip will perform the app ID and content ID. Those tasks done by the Jaguar chip, and it will just provide the result application. So for HTTP GET, my Palo Alto Firewall identify this traffic as a web browsing. Application is web browsing. Application web browsing, content ID will check for any type of malwares and all. And after that, this packet will go here. Now, this is the example for HTTP GET. Now let me just enhance my discussion. Let me just go beyond this. Now you got the point here. When your Jaguar chip come in a picture, when we have a layer 7 data. Now let's suppose, oh, now let's take an example. I have a server here. Now let's take an example here. Just put your attention, guys. This is critical. Okay. Now put your attention. Let's suppose now. Now let's suppose I have established this connection. Let's say this server is running the service on port number 443. I've established that connection with that. Now I am doing the communication. Now see, now SSL based communication is happening. Let's suppose I have received the packet number 100. So packet number 100. Packet number 100 reached to the Oction chip. Oction chip will do ingress stage, flow lookup, slow path it will bypass, go into the fast path. Now you in case of SSL, what is this packet is encrypted, yes or no? Because in SSL handshake packet is encrypted. If your packet is encrypted, now when this Oction chip will forward this that encrypted information, layer 7 information is encrypted. Or what it we will use the for the encryption, it is encrypted by the TLS, transport layer security. Now tell me one thing, if my Jaguar chip will receive the encrypted traffic, do you think it can able to do anything? SSL decryption is not configured at all. That feature is not enabled right now. Now tell me one thing, is my Jaguar chip able to help you? Encrypted traffic it cannot able to read. If it will not read that data, that time what it used to send, it will send one message. Because Jaguar chip knows I have received, like for example, I have received 100 packets, but generally after getting multiple packets, like 5 or 6 packets, or the layer 7 data when it will receive, and if it is receiving all the encrypted packets for this session, then what it will mention? It will mention layer 7 completed. Layer 7 completed. This message it will send towards Octane chip. Why? Because Jaguar chip is not able to read that data. If it is not able to read that data, which means it cannot able to do anything. So it will just send one message. Layer 7 processing is completed. When it will send this message, so Octane chip will understand, yes, because now I don't need to forward this data to Octane to Jaguar chip, right? Because layer 7 data is already completed message I got. What it will do now? Now this type of packets, what it will do, it will offload. It will send one message to Tiger chip. Now going forward, whatever packets you will receive for this particular flow, you have to handle. Because guys, this chip can able to perform the flow control. This chip is able to do the flow control. If you remember here, it can able to do the flow control, right? Flow control means it can able to perform this task. Okay. Now, once this message is received by the network processor, now because now this Octane chip is instructed this Liger or Tiger chip or the network processor. Now going forward, you have to handle this packet. Now this packet go here. Now whatever the communication will happen between this particular client and server, going forward for this session, or let's suppose the session ID is 1001. For this session, all this communication is handled by the Liger chip only. Now those packets will not go here to the Octane chip. Now everything is handled by this Liger chip or the network processor, which means it is handling the offloaded sessions. And why this chip is offloaded? Because this is some enhancement. This is some type kind of optimization, because otherwise if we have not offloaded that session, then all the processing my data plane CPU needs to do, which is Octane chip, right? But I have offloaded the some load from here. Now Liger and Tiger or the network processor is doing the task. So see, I think you have not understood. I said there is no decryption configured. If decryption is configured, then the story is different. What I said, no SSL decryption. If no SSL decryption, which means that is not configured at all. And my Jaguar chip is not able to read that data because I'm receiving the encrypted traffic. So if, see, let's suppose, like, let me tell you the basic example. Let's suppose in your team, you have a 3 members. Let's say there is a one email which is intended for your teammates, not for you. And if you will receive the emails every day, if you will receive the emails for every day, which are not for you, they are for your friends only, what you will respond on those emails? You just simply say, simply reply, Please exclude my name. They are not for me. It's the same thing my Jaguar chip is doing. Please stop sending the packet for this session because I'm not able to read anything. Information is encrypted. Why you are sending? Right? Now, if let's suppose we have configured the SSL decryption, then the story is different. SSL decryption is configured that time. I will provide the encrypted information. I will provide the decrypted information which is read by this Jaguar chip. If my Jaguar chip is reading something, then those type of packets will go here. It's a normal, then it will work as a normally at per the normal process. But here I just wanted to tell you when your network processor come in a picture. Okay. So guys, if you have observed here, like this is the parallel processing architecture because we have a dedicated processors here at my data plane level. At my data plane level, I have a dedicated processors and they are working parallelly. Yes or no? They are handling the data parallelly. There is, are you able to see any type of dependency for the resources on each other? No, they are working parallelly. They are processing the data parallelly, and that's how Palo Alto architecture is the parallel processing architecture. I hope you have understood the architecture and as well as the data path. This entire thing is known as data path. Whatever I have drawn here, this entire thing is known as data path. Now, I have included 2-3 things here, like in your signature match procedure, right? There is this processor is only responsible for app ID and content ID. So you know guys, in this particular engine, there is a 3 algorithms: DFA, AHO, and PScan. Those are the code or program which are running on top of this particular chip, and those particular code will help this particular engine in the app identification and content identification, right? Because you know we need some type of code, some type of program who can instruct you have to do the task in this particular way, and that particular way is defined by those algorithms. Okay, so those are the use of those DFA, AHO, and PScan. Okay. PScan is the very latest algorithm. Okay, I have not included so many things because you know otherwise you got confused. But if you will understand the architecture, like we have a Marvel and Petra chip where my ports are connected. Then this Marvel and Petra chip has a connectivity with the Liger or Tiger chip or with the network processor. Network processor has a connectivity with the Octeon chip or the data plane CPU, and then data plane CPU has a connectivity with the Jaguar chip. And you know guys, those particular chip, they are interconnected with high speed fiber links. Those are the high speed fiber links, and the name of those links is the joy links. Links mean just I think some type of cable they are using, some type of fiber media they are using between those chips to exchange the data, to exchange the data. Okay, so those links is known as joy links. Now this is the architecture of guys old devices, first generation boxes. Okay, I'll come again here guys. Okay, but before that, still we are on the SP3 only, but we have discussed so many things. Now let me show you something. If you will, are you able to see this particular architecture or the data path? This is the data path of Palo Alto 5200 series box or the latest box. 5200 series of the second generation box. In 5200 series boxes, basically your Marvel or Petra chip is replaced by the Qumran chip. What was the chip name now? or what is the name of switch fabric or the interface fabric where our ports is connected is the Qumran chip. Your network processor is still it's a FPGA or S6 or the session offloader, but they have renamed this chip or they have done the rebranding of the chip, and now this chip is known as FE100. What is the chip name? FE100. And after that, we have a Octeon chip. So data plane chip is still there, Octeon chip, DP0, DP1, and DP2. Then we have a signature match processor where they are having CE100 chip. So your Jaguar chip is replaced by the CE100 chip. That is the data path of latest Palo Alto models. There is one question. As you said, there is no dependency on the chip in case of connectivity break or chip overutilized. In any case, what happen after that? So guys, if your chip is overutilized, then that is the main reason we have a data plane troubleshooting actually. That's why we have to do the DP-CPU troubleshooting. What do you have to do? You have to just raise the tag case and they will perform the data plane CPU level troubleshooting. So inside Palo Alto there is a tools are available. When when you will say the tech support file, TFS file, this tech support file they will upload into those tools, and those tools they will basically give you everything, like how many packets we are having at this chip, at this chip, at this chip, how many drop, all those graphs and everything you will get. And there is a one daemon is also there, dp hyphen monitor 0, dp hyphen monitor 1, dp hyphen monitor 2. Those are the daemon log file which we have to read and we will get all the solution. Okay, like we used to face lots of challenges actually at the data. It's not like that those chip is not over utilized. If we will get a lots of traffic, then definitely they will get overutilized. Okay, but multiple things are there actually. Apart from those chip, you will face most of the time you will face the problems at the CPU levels actually. Or if you have heard the name of descriptors, so there is a one terms at the CPU level, we have a descriptors. So we have a on code, on chip descriptors. So like three type of descriptors are there. Then those descriptors label troubleshooting we have to do. So that's a like very in-depth information. Okay. How those they will communicate, how your CPU get work, right? So there is a totally different discussion here. I don't want to go on that one, but it's used to happen like that. There is a multiple logical or the packet forwarding units are there. Okay, those units we have to understand. We will read those particular diagrams and all. Palo Alto Firewall is not silo, Anil, Amit, sorry, it's not silo. It's the most fast firewall if you will compare with the other firewalls. Its throughput is very high in comparison to the other vendor devices. Which jobs you are talking about? You are talking about the commit job. See, commit job does not matter. Okay, commit job will not matter. If you have a high end boxes, your commit job will not take much time. Commit job totally dependent on the configuration size. If you have a high huge configuration size, so the recommended configuration size is 80 MB. In case of panorama, in case of firewall, 55 MB. If your configuration size or that file size is very big, then you always see this particular slowness in the commit. Okay. And commit is not having any relations with those chip and all. Okay, commit. So let me tell you one thing, because you have asked this question. So in case of commit, basically, this is the daemon who is responsible for your commit related task. Management server. Now, this particular functionality is offloaded with one more daemon called config-d. So this is the daemon who is responsible for your configuration management, and commit is totally depends on this daemon, how this daemon functions. Okay. If your config size is big, definitely it will take some time, but it's not like that. If your commit is happening very slow, then have you seen your traffic is also not moving that time? User faces slowness? No, they never face the slowness, right? Commit is a part of your management plane. It's not dependent on the data plane. And those particular, this architecture is only totally for the data plane. Management plane is totally separate. Okay. Now guys, one more thing I wanted to cover here again. Let me come here again. So guys, I hope now you got the some idea what is the functionality of those processors. And I hope this is also built in your minds, like data plane is divided into three another planes: network processor, security processor, and the signature match processor, right? If you got this understanding now, because as I have started, this is the management plane. It has his task to do. Data plane is further divided into three another planes, and those planes, they will able to work parallelly because they have a dedicated resources on each other. And one more benefit you will get with this architecture: see, if there is any problem in your data plane, any of your chip is not functioning properly, you can able to restart the data plane. You can just restart your data plane. You do not reboot. You don't need to reboot your entire box. Not required at all. Just restart your data plane. That functionality you will get in your Palo Alto Firewall. Your data plane only, your data plane will reboot. If there is any problem in your management plane, let's suppose in your management plane, your commit is failing every time, you can restart the config daemon or the management server daemon. Let's suppose your user ID feature is not working. Just restart the user ID daemon. Let's suppose your IPsec VPN is not stable. You can restart the IK manager daemon. Those particular processes we can restart, but in other boxes, what we have to do, we have to restart the entire box. That is also one more benefit you will get because of this type of architecture. Another benefit, tell me one thing. Let's suppose somebody has launched the DDoS attack. From internet, somebody has launched the DDoS attack. Then with this DDoS attack, your data plane will affect. Your data plane will affect, but your management plane is safe. You can log in into your firewall through management plane, and you can do the necessary configuration to prevent from this particular DDoS attack. This benefit also you will get. If your management plane is under the DOS attack, then your data plane is safe. Your users traffic will not impact. Users will able to do the packet processing. So those are the also some benefits you will get because of this parallel processing architecture. Now guys, tell me one thing. Have you understood the parallel processing architecture? Have you understood the parallel processing architecture, guys? Great. I see one question like in OS upgrade always we have to reboot here. Without reboot, how you will load the new OS? You are changing, right? What is OS? OS like a we have a hardware, then we have a operating system, right? If you want to upgrade the OS and you want to use that new OS, then definitely you have to load that OS on the new hardware, right? And for that we have to reboot the devices. Now guys, let me just cover your single pass software. And put your attention guys, I will not repeat, okay? I don't have a habit to repeat the things. Okay, now what is this single pass software? So you know guys, this, this single pass software, this particular thing is applied at the content engine. Otherwise everything is the serial, but single pass software stuff is applied in your content engine. Okay, now what used to happen basically when your layer 7 information from the packet is handed over to the signature match processor, when this information, layer 7 information is received on the signature match processor, and who will send? Your Octeon chip or DPCP will send this information to the signature match processor, right? So what used to happen in signature match processor, you have seen most of the time RAM you have seen. So what it used to do, it used to store that information like this. Looks like a wheel here. When this information is received, this only layer 7 information is received, what this signature match processor will do, it will store that information into those particular memory locations. Those are the memory location where it has stored, let's suppose, this layer 7 information. And you know, in signature match processor, if you remember, that processor is responsible for two tasks: app ID and content ID, yes or no? Right? So you know guys, what happens in this particular content engine, we have a here, let's suppose we have here antivirus signature database. We have a anti-spyware signature database. Here we have a vulnerability database. Here we have a URL filtering database, or basically URL cache we are having here. Then let's suppose here we are having file blocking database, file database. Here we have a wildfire database. And here we have a app ID database or decoders, protocol decoders. Okay. Now that information is saved into this memory location. And how many times we have saved? Just once. I have saved this information. And you know, guys, what used to happen? Those particular database, what they will do? Now they will fetch this information and they will match. They will fetch this information together at the same time. And they will match against the databases. Means I have stored the information once one time on my signature procedure, and all those particular database check happens. And whatever the verdict I will get for this particular checks, like if there is a virus detected, then it will inform the same verdict to Octi on chip, like malware is detected or spyware is detected, or this is the URL database, it will inform to the Octi on chip right away. An Octium chip will do the necessary action. If nothing, if data is clean, then it will inform like data is clean. So you know your information is saved only one time in the memory location and process against all your layer 7 features. Your packet is only going in this layer 7 or content ID processing happen just in single pass. Now, let me just explain you the architecture of multipass first. I do have a multipass architecture somewhere here only. Yeah, this is the multipass. Just give me a second. Let me save this. Daemon architecture. Mhm. I want to take the screenshot for this, but where is snipping tool is not responding. Oh, it's there only, sorry. Okay, I just took this screenshot. So I'll take this also for the reference purpose. Let me remove this. Okay, now with this multipass architecture, what used to happen? Guys, if I'll take a reference from the Cisco product portfolio, and I'll take an example of Cisco FTD. I'm not an expert on FTD, okay? But see, if I'll talk about the Cisco FTD, Firepower Threat Defense, it's a combination of 3-4 product, right? It has a ASA code, then it has a IPS code, it has a AMP code, Advanced Malware Protection code, and it has a WSA code. So what they have done, the actual code which are there or actual operating system which they are having for ASA is known as Lena. So in FTD, what they have done, they have put this Lena engine. On top of this Lena engine, for the IPS functionality, they have put the Snot engine. And on top of this Snot engine, they have put the AMP. Then on top of this, they have put the WSA. So now what used to happen with the multipass architecture, guys? When we receive the packet, Packet will go through with layer 2 to layer 4 processing, port or protocol based security. Then they will apply the firewall policies. Now, see, now you can see when your packet reached into this for URL filtering on WSA code. Then again, your layer 2 to layer 4 processing will be done. Protocol based process policy will be done. Then your URL filtering will happen. Again, your protocol and protocol based policy is done. Then your IPS will happen. Again, here port and protocol is repeating. Then your AB is doing. So you can see here your packet processing is happening multiple times. Those tasks is repeating. Yes or no, guys? Here your tasks are repeating or not? This is the multi-pass architecture, and that was the problem. That was the problem. See, your packet is got processed, come back to the Lena engine. Again, packet processing is done. Then it is going, come back to Lena engine, then layer for processing. Which means what they are doing. If you will understand this properly, what they are doing, this layer 7 information, they are giving this layer 7 information here. Layer 7 data they are giving here. Layer 7 data they are giving here again and again. See, for completing, coming back, then layer 7 is forwarded to IPS, came back, then layer 7 go for the AB. It's repeating. There is no, it's a multi-pass type of architecture. Why? Because your packet or your layer 7 information is saved multiple times into the RAM. And my Lena engine needs to provide this information multiple times. So if I'll draw a diagram like this, like I have a Lena code here. Here I have a snot. Here I have a URL filtering WSA, and here I have a AMP code. Then what I'll do, first it will provide layer 7 here, processing done, come back here. Then layer 7 here, processing, come back. Then layer 7 here, come back. So here your information is providing to 3 different engines. They will save, they will process, right? So here tasks are repeating or not. So that is your multi-pass architecture. But in your Palo Alto single pass architecture, what happening? Everything is just in one go, right? Now you can ask why Palo Alto is able to do like this. Why other vendors is not able to do this? So guys, it depends on the PAN OS. PAN OS or Palo Alto operating system is designed in such a way it supports the or PAN OS is programmed in such a way it supports this type of architecture. But other vendor fire, what they have done, like Cisco, Lena was an engine on ASA who can able to do layer 2 to layer 4 processing. And after that for IPS, what they have done, they were having the IPS box. Cisco was having one IPS box and it was using it's not engine. So what they have done? They have not designed their OS from scratch. On top of Lena code, they have just added the snot code. If your code is also not is a different code altogether, then how it can able to perform the single pass processing? It cannot able to do that, right? Because this code is running separately. This code is running separately. Okay, got it, guys? Then for your file blocking, send or your wildfire type of features, they have a AMP code they are running here, which is also separate code. But Palo Alto operating system is designed from scratch like that. So it can able to do the parallel processing. And if you remember, guys, if somebody has done some upgrades on Palo Alto, you always have a different operating system code for different vendors, different Palo Alto firewall models. For PA 200 series, you have a different. For PA 5400 series, you have a different. For PA 3200 series, you have a different OS code, and for PA 3400 series, you have a different. Or for PA VM, you have a different code altogether. Why we have a different code? Why we have a different type of codes? See, this is a question, right? This is a valid question, right? Why we have a different type of code? Because of the architecture. Each and every vendor have a different type of architecture, different type of chip, right? Chipset. And on those chipset, different type of code needs to run differently. Now let me give you one example. For PA 820 box or 850 box, this particular box only have single chip, which is Octeon chip. On this box, all your interfaces are connected directly on this chip. There is no network processor, no signature match processor. That's just a single chip. It's just a single chip. This chip is capable, as I mentioned, this chip is capable of layer 2 to layer 4 processing, right? Then who will do the layer 7 task? Who will do the app ID? In that case, if you remember, I have mentioned those algorithm, AHO, DFA, PScan. Now those algorithms used to run on this chip as well for app ID and content ID, and they have a segregation at the software level. They have a segregation at the software level, not at the hardware level. It's a low end box, right? It's a low end box. Okay, because when you will put a different chipset on a different model, that's how your cost will increase, right? Totally depends on the cost, and everything is on the cost. Okay. So like low end boxes, you will see the Octane chip. In some of them, network processor is not there. Only the signature match processor will be there. But if you will talk about the high end boxes like 5200 series, 5400 series, 7000 series, 7500 series, they have a architecture and your actual parallel processing applied on those box only. Those high end boxes, only your actual processing will apply. They have a this type of architecture. Okay. Now guys, tell me one thing. Is this SP3 is clear? We have around 90 minutes of discussion or more than 90 minutes of discussion on SP3. Everyone is clear with this? Are you guys there? Great. Now then let's have a break for 20 minutes because even though I am just exhausted.